I'm technical lead on the Service Bus team. What that means is I set the technical strategy for Service Bus, and I do a lot of prototyping, and I'm working with customers directly. So I'm on the PM side of the technical team, of the product team in Redmond. So what I'm going to talk about, we're probably not going to go through all the pieces, given that this is a 75-minute talk and I have 30 minutes left now. So we're going to skip a few pieces, but we're going to go about the what and the why, because that's that's important. I'm going to show you a little bit of the SDK and the tooling story. I'll talk about brokered messaging and relay messaging, what we have, and I'm also going to talk about the pricing options that we have. I have 60 minutes. Did you extend my time? It was planned until 9:30, so I have 60 minutes. I can relax. So now I can still make football jokes. Well, I'm really sorry. No, I'm not. All right, so what is Service Bus? Service Bus is an infrastructure that allows you to connect things together that are sitting on premises and are sitting inside of the cloud infrastructure. We actually have a number of customers who are using Service Bus completely independent of Windows Azure, which are just taking assets that they have and they're interconnecting them through the Service Bus. The Service Bus is an infrastructure that both is a middleware infrastructure for applications you run in the cloud. So we call that scenario intra-app messaging, or for applications that probably are just attached through the cloud, but where both of the pieces that you're connecting are running on premises. So looking at the slide, let me give you a few scenarios. One of the things that we're seeing, for instance, is, and this is the household appliance, increasingly seeing is interest in cars, in household appliances, in devices that are sitting in the household, or devices that are kind of on the road that need to have connectivity. Where the first piece of connectivity is obviously what the mobile carrier is going to give you, the mobile connectivity that you get probably from Vodafone or other carriers. But then with the second leg, really into the data center, is one where you need to deal with a lot of data, with a lot of ingress data, telemetry information coming down, command and control information coming up, that you need to go and manage that somewhere. So we see an increasing number of customers, large enterprises actually, coming to us and say, hey, I have these tens of thousands of devices, I want to go and connect them up. And so that's one of the scenarios that we see. Another scenario that we see is individual addressability for phone, tablets, PC, classic clients, where you have anything from a game to line of business applications, where you need to have connectivity for, let's say, a phone. And so the thing with the phone is mostly connected, but not always connected. If I want to send a message to an application that's on this phone, the application will be dormant. Right now it will be very dormant because I ran out of battery. But if the application is not alive, and I want to send it a message, well, in Windows Phone, as well as in iOS, the application is not alive until the user activates it. So if I want to send a message to a user having a particular device, I need to have a place to store that data, to store the message. So you need to have some kind of a mailbox for that device. And so pops up or messaging is also something interesting there. We have line of business applications that exist. Now, line of business applications that exist, you can run in the cloud, obviously, and we're trying to make the infrastructure interesting for those kinds of cases. But there's plenty of line of business applications, many of which you run or help with running or build, that are currently obviously running on premises. If you're a medical doctor, if you're a lawyer, if you're a tax advisor, if you have information that's subject to regulation, that data, those applications are not easy to move into the cloud because of regulation, because it's that's a thing, to move those things out. Medical doctors are highly regulated with privacy laws and privacy regulations, but you want to be able to get at that data. So we're seeing a number of customers who have use cases where they provide for iPad or for phones the ability to go and reach into these private data silos, into the line of business application that the doctor runs in their office, so that they can be on the road, that they can visit a patient, and then get the complete patient file kind of in a digital form with an intermediary service which runs in the cloud. You have point-of-sale kiosks that are sitting out in the world. We have several customers which have either point-of-sale kiosk solutions, where you have large machines that are sitting out somewhere at a drugstore in the United States, where you can walk up and you can rent a DVD for a day. Runs through your credit card, so you run your credit card in there, you register, and then you can go and effectively pick a DVD. It comes straight out of the machine, you take that with you, and then you return it the next day, and you get charged $1. If you want to rent a game, it's $3. If you want to rent a Blu-ray disc, it's $2. Those things need to be connected, because you don't want to go to the machine, if you have the chance. Let's say I have one of those on the way from work, so I'm at Microsoft and I want to get a DVD. Instead of stopping on the chance that the DVD I want is available, what I can do is I can go to the website and I can effectively browse the catalog of the machine directly, and then reserve myself in that machine my DVD, and then go by and pick it up. So that's something that we help with Service Bus, for actually connecting all these machines that are sitting around retail stores, and where we help actually reaching into that machine and actually doing the reservation in that box. Because all of the scenarios must also work if the machine gets knocked offline. Then it also needs to continue to work. So you see that there's a lot of computerized devices sitting kind of at the edges of the network, which are connected. We have several what we call entities in Service Bus which service these concerns. We have queues. That's the most obvious one, because everybody knows what a queue is. There are topics, which are publish, subscribe infrastructure. There's sort of like a queue, you enqueue data. And then you have subscriptions, where you can have multiple heads kind of over the same log that you're creating by enqueuing, where you can have multiple subscribers getting the same kinds of messages. We have relays. I'm going to explain that in detail. Scott already talked about this, where I have a way to listen from a service that sits on a local machine. Instead of on the local machine, on the local network, we listen on your behalf in the cloud. We have notifications. That's a new feature that we're hopefully going to have in a public CTB form towards the end of the year. When I mean end of the year, I mean end of the year. So this might quite well be Christmas, or it might also be December 56th. We'll see. So we're hoping towards the end of the year. And then there's bridges, and bridges is a feature that you see coming out of the BizTalk team. There's currently in labs, in our App Fabric Labs environment. That's the only place where we still retain the name App Fabric, just because we have the domain name there. That is, we have the EAI and EDI labs sitting in there, and that's something where the BizTalk team is figuring out what the right story is for the cloud. And you're going to see that story also evolving. So there's a number of pieces inside of Service Bus, and I'm going to talk about a few of them today. So one of the scenarios, I already alluded to this, is a tax advisor scenario. And you can take that tax advisor scenario and also use that for medical doctors, or use that for lawyers, or use that for effectively everywhere where you have a scenario where you have these on-premises systems that exist and you can't move them, and the ability to go and talk to them from the cloud. So we see this as a pattern already, that we have a number of ISVs providing SaaS solutions which are doing exactly this pattern for various different verticals. So there's Fred's tax advisor's office, Peter, Mary, and Linda. All of them have tax advisor offices. They are using Litware's software to run their tax advisor office. Litware now sells them also this mobile application gateway. And that is complemented by a wonderful app that they can go and buy from the App Store on iPad. And let me be frank, I'm a server guy. I don't care. Right? All I care about is that that I can service clients. Whether those clients are running iPad or Android or Windows Phone or Windows 8, ultimately wearing my server hat, I don't care. It's all fine. And we're going to make those things completely compatible. Wearing my Microsoft hat and shareholder hat, I certainly want them all to run Windows 8. However, I will want the iPad to be happy. Turns out that a lot of our customers are building applications, wonderful experiences for the iPad. Certainly we want to convince them to build wonderful experiences also for Windows 8. But in this particular case, we have two concrete, real customers. One of them is LexisNexis. I can talk about those because we have a PR agreement with them, and they're building these applications for the iPad. Now, the nice thing about the iPad is that it has a great way to build wonderful interactive experiences, probably better than you can build them for a regular PC because of touch, something we hope for also with Windows 8. So what they do is they present, in the case of LexisNexis, legal documents to the customers, and you can go and very nicely interact with them. So this mobile gateway basically takes the data that comes from the client side, reaches into the client side, grabs a bag of data, and then effectively presents it in the form as web services to the iPad app, which then talks to it. So that's a gateway solution. So how do we support this? There's Service Bus in the middle, and Service Bus kind of provides that connectivity. It provides it through the relay. So the SaaS mobility gateway is running as a multi-tenant service. A request comes in from the app, which is installed and is provisioned with a user identity. The middleware gateway will then figure out which identity maps to which of tax advisor's office, and then we'll use the relay to talk to that tax advisor's office. The tax advisor's office, and that's true for most of the customers in the real scenario, is just running behind DSL. Right? They just have a normal business network connection that a normal office would have. So there's nothing special about this. This is just a run-of-the-mill DSL connection with no special features. There's no static IP address. There's nobody on site who could deal with the network. This is just what you get if you sign up for DSL. So all the magic for creating now outbound connectivity or inbound connectivity lies in the Microsoft.Service Bus assembly. In that piece of software that they use, that we give them in the SDK, that we use, and which is effectively creating this inverted direction of traffic, which allows them, with those applications sitting in that office, to listen for traffic, even though there's no inbound port open, there's no inbound, there's no discoverability of that endpoint, so we're creating that with Service Bus all for them. And then there's, on the way out, also, this is a topic, a way to go and send events and publish those events into the mobility gateway so that the mobility gateway can then go and notify the user if something particular happens. And we're going to support that in the future. That's that blue arrow. Also with the notification service. Well, we will be able, straight from inside of Service Bus, enable notifications into Windows 8, into Windows Phone, and into iOS, where we will be able to send push notifications into the shell. So that's a general scenario, one of the few scenarios, or a number of scenarios, that we see emerging with Service Bus, where we're creating the connectivity and we're creating effectively the flow between on-premises software or software in the cloud and application clients that are sitting on top of it. So relay messaging, to give you a little bit of an insight of how this works. Here's a very simple demo service. What you see here is a, let me make this a little bigger for you because no, I'm actually going to do that a little differently. Well, look, it's lunch. How could it be lunch? I haven't changed my, I should have turned this off. So here's a normal web service host. So this is the WCF web programming model, not web API. And so I have a self-hosted web service host. The type is simple service. And I have an address. The address is composed of my service namespace that I have on Service Bus with the suffix simple service. Service namespace is a concept, or namespace in general is a concept that we use in Service Bus to create you a space of names, of paths, a tree of names that you can go and manage and you can place things into. It's like IIS. IIS has this concept of sites, right? You could separate sites in IIS, and a namespace is like a site in IIS, but that's the concept that we have in Service Bus. And as much as you can take an IIS site and map multiple virtual directories into a site, you can map those relay endpoints into a namespace. So I have a namespace here. It's called CVDemo-E, CVDemo-E for Europe. That we're going to use here, and I'm going to open up this service, this simple service on this. So the implementation of that is here. And it is, when I say simple service, I mean it. It's, that's all. So it's just returning hello, and it's simple web get, and I can say Windows Azure User Group. All right, and we're going to run it, unless we're running it already. Yes, we are. Let me go and kill this one. Okay. So what happens now is that I'm going out on, yep. So I actually have a special setup because, a little bit of a special setup here because we have some networking specialties here in this house. So I'm listening in a little bit of a different way than I usually would. I'm actually listening on a dedicated TCP connection so that I have two modes here. I have a TCP connection mode and I have an HTTP connection mode where I can go either through a listening port out on TCP or through HTTP out. I actually chose to go out, I spoke through HTTP here because the outbound ports that we need to listen actually happen to be blocked in this building. So the outbound connectivity I can only create using HTTP port 80 or HTTP port 443. So in our case, we go out through port 80 here. So that's a switch that happens, and I actually turned that off or have a somewhat special setup so we can save the probing time here because we're automatically figuring this out. So there's now at this endpoint, get data. If I hit this, I can get that the data. And you can actually do that too. So this is now a public endpoint. This is the only thing I have here is power. If you go and watch this, is power and the connection here to the projector. So there's nothing special. I'm just sitting on the wireless network. And I'm calling in, and so now I reached through Service Bus, actually through the data center here around the corner, through Service Bus into this machine. So this machine sits on this network, it exposes a public endpoint, and I can hit that public endpoint from the outside world. I have explicitly turned off the access control protection that I have on the system, usually. So typically, if you leave everything at the default, to call this endpoint, you're required to bring a token to us that you acquire from the access control service. We automatically federate with the access control service to get that kind of integration. I turned that off here in this case so that we can actually cleanly hit this. The configuration for this sits here, so I'm going to turn the service off. So let's turn this off. Now what happens is I hit this again. You know, we're going to get our discovery feed. So this is the feed. We have a infinite nested hierarchy of feeds, and that's what the default view is, because there's no longer anything projected into here. So if I go and change the configuration here, and effectively change the security, I go and change the security setting by simply commenting it out. So this is now, I had turned the relay authentication type to none, and I'm going to restart this. I will get the same setup, I will get the same URI. But if I hit this now again, it will say the request contains no authorization header. So there's no authorization token. So in this case, it's required to bring an authorization token. The way the ACS integration, the security integration works for Service Bus is that if you have a service behind us, we are acting as an externalized DMZ with an additional security layer on top of it. So you need to acquire a token, usually from ACS, from the access control service, and pass that into the authorization header or in the Service Bus authorization header. That's an alternative version. And only then we will go and pass through your requests. So we're providing an extra layer of protection in front of your services. You can turn this off, as I just did, or you can leave that on, and then kind of have a two-factor authentication model. We're trying to be as transparent as we can be to your end-to-end relationship, but have that extra protection layer if you need it. So by default, if you expose the services, it will never be unprotected. It will always be protected, but we give you the option to turn that off and then just have a normal relationship and be as transparent as we can be for those services. So that's the relay. And I haven't spoken to anybody in this building and haven't done anything special. That's how you can expose it. What the relay also supports is load balancing. I'm going to show you that with this sample here that I'm simply going to run. The sample is doing something similar. It has a set of clients. And we're going to start 5 clients instances, I believe, or 6. And we're going to create 3 listening services. So I'm going to start that. So I have 3 listening services that are sitting on this side, and I have seven senders, and the listeners are just getting started. They're starting up now. They're all listening, and now the senders. There's a little bit of a delay built in. I believe they're waiting another 15 seconds, and then they start sending messages, and they're actually those windows are color coded. So here we go. So they're listening on the exact same addresses. What you see here is that they're getting load balanced. So the sessions get load balanced. So this is session load balancing. So we're using here the NetTCP mode of the relay. So a NetTCP session gets established, gets load balanced to one of the receivers, and then that session gets pinned to that receiver. If I go and kill one, so let's go and kill that red one. You're going to see an error showing up here, and there's error handling in here. So and this guy will now go and recover and then use the other ones. So you get failover, and you get load balancing all the same way, and that's simply by hooking up into the same relay endpoint. That works for HTTP and works for TCP. So if you have a set of servers that are sitting behind the firewall, and you all hook them up to the same name in the namespace, you can hit them all, and you get automatic load balancing with this. So we're acting not only as an externalized DMZ, but we're also acting as an externalized load balancer for TCP connections here. So what we give you with the relay is NAT traversal, firewall traversal, load balancing, and location transparency. Location transparency in the sense that this service here now has a name, right? It's called, well, in this case, if we run this on the same namespace, it's cvdemoe.servicebus.windows.net/Clemens/lbdemo. That's what the name is. And that name is completely independent of where this thing lives, whether that sits on this network or whether I run this from anywhere else. If I switch IP addresses, if I'm sitting behind dynamic IP, the thing will always have the same address. So it gives you location transparency on where that service is living. So let me go and close all this up and clean it up. Just making sure that I'm just killing the right instances. So key capabilities here, we have relayed one-way unicast and multicast. So there's a binding, I'm going to talk about bindings on the next slide. There's a binding that's called the net event relay binding, which allows you to have not the load balancing feature here, but there's a one-way binding, which exposes only a one-way channel. Your WCF contract needs to have is one-way equals true for all the operations. And then we can do multicast. So you send one message in and that actually lands at all the listeners. We have direct connect for net TCP, which allows you to effectively bridge away from the relay. If the machines are close to each other, then we're going to try to connect them directly if we can. We have relayed HTTP, where we're listening for HTTP or HTTPS at the edge. And then you've seen the endpoint protection with access control by just turning on this integration with ACS using the switch on the binding. What's coming soon is something that's currently dubbed the IIS Hybrid Cloud Bridge. It's something that I'm currently working on. We're still looking for a nice, we have the final name, somewhat. I'm still looking for a nice code name for it. It's kind of funny. And we're going to develop that as an open source project. I'm going to start, I have a number of assets that I've built in the past 2 years that we're going to put together there. So there's going to be an IIS integrated management experience. And I'm going to put two samples together that I've built in the last few years called WebBridge and PortBridge. And I'm going to fuse them into a single infrastructure. And the goal for that is that we can give you a piece of software that you can add into IIS, where you can effectively just take a site out of IIS, SharePoint, Exchange, no matter what it is, whatever runs in IIS, and can go and take that and expose that out to the rest of the world. So if you are running a SharePoint site in a small business and you want to go and expose it out to the rest of the world, you'll be able to do that with the IIS Cloud Bridge. The other side of the IIS Cloud Bridge is not going to be Service Bus directly, but a little module, a little web module that you can plug into Windows Azure websites or into a web role that then acts kind of as the counter site, the reverse proxy for your site, and that will then go through that tunnel. So the programming model for the relay is a WCF programming model. You have a number of bindings you can use. There's a web HTTP relay binding, basic HTTP relay binding, WS2007 HTTP relay binding, NetTCP relay binding, all corresponding to the respective WCF bindings. The special service bus binding, one I already mentioned, net event relay binding, that's the multicasting one. Now, if you don't program WCF, again, the thing that's going to help you there is this IIS bridge, which is going to allow you to go and plug this into IIS. Another reason why we want to do this as an open source project, where effectively I'll be collecting most of the code and wire it together so it basically works, is that we also want to make it possible to make this work on Apache and on all kinds of other Windows-based servers, and eventually also on Linux-based servers. And for that, we think the best way to do this is just do it in an open fashion and have folks contribute if what's currently there is not satisfying their current needs. So right now it's all WCF based, and what we try to do is to make this more open, also with some investments that we're doing in the messaging space. I'll get to that later. The basic functional model for the relay, just to make sure that you understand what the magic here is, because it seems a little magic that I can go and expose a public web service from, a conference center that I haven't been to yet, is the principle is actually fairly simple. We have a receiver, that's this machine, that's going to service bus and is registering itself at a name. So it goes to solution.servicebus.windows.net, whatever my namespace is, and some name /A/B, and it's reserving that name for its use. That is exactly the same gesture that you use with IIS when you are registering for with IIS or HTTP sys to listen for you. You walk up to HTTP sys and you say, if you get a message, if you get requests on this port with this host name on this path, call me back. Same story here. We just do that gesture over the network. So we create an outbound connection. We send a package of data up to the relay. The relay then remembers this and holds onto the socket. And we're super aggressive about recreating that socket connection. If you have a listener and you close your computer, like you put your computer to sleep and you bring it back up again, within the next 5 seconds of reconnecting to the network, will be also reconnected. So as soon as you open that connection will be there as long as there's network. We're aggressively reconnecting. That path is happening over 2 kinds of network connections. TCP, port 9351, and if port 9351 is not available, then we're going to go over port 80 using a pair of HTTP requests along GET and along POST. Requires HTTP 1.1 with chunking support. Because that's an obstacle through a number of proxy servers, we have been asked by a number of customers to not be so shy as we were. And so therefore we're going to add an HTTPS mode where if the HTTP thing doesn't work, we're simply going to duck and go and run that through HTTPS, which will then get us past most of the proxy issues. So we will be as aggressive as we possibly can be. And as WebSockets becomes available, we also want to support WebSockets as an additional option here. So we'll have 4 options to actually get out and create that connection, which should work for practically every environment. The sender then comes to another front-end node in Service Bus. We typically run with 32 of these front-end nodes in a scale unit. And we'll go and try to do a request. If there's no route to the desired receiver, what we'll do is we'll send a control message onto the naming fabric. The naming fabric will then forward that down that existing control channel, and the receiver will then rendezvous a socket with that machine at the front. And once we've done that, we now have a relayed socket connection between those 2 parties, and that's where your traffic goes through. So effectively, all the traffic that comes from that goes to the receiver is based on the receiver making outbound requests, and that's how we do the NAT traversal, right? Because outbound is okay. Isn't that dangerous? Well, it's not more dangerous than going to a website and downloading a virus, right? That's what it is. It's if you allow outbound connectivity, you allow this. So, and it's different from it is different from getting inbound traffic through a normal network connection, because we're only giving you that traffic, which is legitimate as per that protocol, legitimate NetTCP or legitimate NetTCP traffic, and we're giving that to exactly that one endpoint that's listening for inbound messages. So that's very different from a network surface where you just open a port and I can go and fuzz it. Because you can't fuzz it. You don't have an open port. You simply have a way for me to deliver messages to you, which is very different. Brokered messaging. Now, brokered messaging is our other set of features. Scott has alluded to this. Scott had a wonderful demo for those people who watched the stream. Probably there's an app that's called Message Scott. And so with that, you can send Scott some messages that show up live on his stream. And that's using brokered messages. That's using the queues and the topics. I'll show you an example of queues and topics and how to use them in here in Visual Studio. So let me open I hope that I'll find it. That would be very helpful. This wonderful MVC3 order site that my colleague Abhishek has provided for me with the wonderful new Visual Studio. The first color monitor which I've ever bought was a NEC Multisync in 1988. It was for coding. And Turbo Pascal looked really nice in color. I'm just saying, I'm not in the Visual Studio team. But you know, lets you focus on the essentials, which are your code. So therefore, there's a good reason. So I have this wonderful little website. The website here is not particularly spectacular. What it does is it allows you to go and order something. Let's go and run this quickly. Wow, they even took the color out of the development server icon. I hadn't even noticed that yet. Well, surely that lets you focus on all the remaining icons. Okay, so that's what the site looks like, right? So you can go and enter your customer name, rocks, paper, scissors. You can go and order them, and then you can go and submit. We're not going to do that yet because I'm going to show you the code first. So what this does is it goes and gets your order and then creates a brokered message, sets its label, and then goes and grabs the queue client that has been set up in this application and goes and sends the order out. So what we're doing here is we have a front-end role. That's just the ASP.NET. That's the ASP.NET side, and that throws a message into a queue that then gets processed on the back end. The reason why you want to do this is you want to decouple those things, because if you have a lot of orders within a very short period of time and you can't process them just instantly, you want to have a little bit of a buffer. You want to have a little bit of decoupling between your back end and your front end. So that's a good way to do this. And then we're going to return to the client. So that's the sender. And now we're going to go and take this and make this a Windows Azure application and add a web role with our new tooling. In here, I have some new things. Also, if you want to take a look at Service Bus, you can actually go and add a new connection here, and you can add a namespace. So I'll go and set one up. So let's go and take a look at one of my namespaces. And we're going to take a look at a busy one. So I go to windowsazure.com. That gets me into the portal, I would hope. It gets me into, mind you, the Silverlight portal, because the Silverlight portal is where currently the Service Bus information lives. We're not in the shiny new portal yet. That's because well, it's coming. What can you do? Not everybody's a friend of the middleware, you know. And I also find that it is a little difficult to read that 150%. Good. So here's Service Bus. I go to Service Bus. Now this is going to take a little moment, because as you can imagine, working on Service Bus, I have a lot of namespaces. And this is my actual account. While we wait, I can do a little dance, or I can further make fun of the fact. Yes, huh? Yes, that's exactly right. Yeah, we were watching football the whole time, so we weren't in the portal. No, the thing is, the portal team is also not blessed with unlimited amount of resources, so they had to go and prioritize other things, and the friends in the middleware are not high up on that list. Come on. Well, the thing stopped. That gives me hope. And it says 0 seconds to next refresh. Well, no, actually, so let me set the record straight on that one, right? That was not our idea. We were told, oh, you need to build serverless plugins. We were like, we need to build what? But that's what it was. All right, so since that's not working, I will do something else. Because all I need is effectively, so I'm going to steal, I wanted to show you that, but I'm not going to show you that, so I'm going to show you something else. I said I'm going to show you something else. Good. So we're going to go to the bottom of this, and, oh, not to the bottom of this. We're going to go to the top of this. We're going to go here. So it's the Ablal test namespace. And Ablal is, Abhishek Lal is my colleague, and now we're going to have his key on video. So, all right. Yes. And we're going to go and add that new connection here, Ablal test namespace, and the Azure key. And so that's one new thing that's new in the SDK 1.7 is the ability to have a view over your namespaces in the Server Explorer right here. So we can see the queues and the topics and all the things that Abhishek has set up. So we have a foo, and we have a TechEd demo, and a test queue, and a topic. And underneath the topic, we probably have some subscriptions. Let's go and take a look at that. There are 2 subscriptions here. So that allows you to effectively go inside of Visual Studio. You don't actually have to go to the portal. But you have to go to the portal to get the key. We're going to fix that. And so you can go and actually create those things in here. You can set those things up. So that gets you fairly close to the experience you also have with MSMQ. If you have MSMQ installed, you can actually go and manage MSMQ inside of here. And so we're now getting onto par with MSMQ in terms of this. We're actually adding more and more features of MSMQ, which we also own. Here, so you'll be able to browse messages from the queues. We don't have that yet. We're going to add that on. So you'll see a number of features of MSMQ kind of starting to appear inside of Service Bus. So that's one of the things that we're adding. So that allows you to get a little bit of an overview. And the other feature is that we give you a little bit of a start for creating worker roles that are using this. So I have the MFC order site that works. And now what I'm going to do is I will add, whenever it lets me, you shall not make fun of Visual Studio while you're demoing with it. So I'm creating a new project, a Windows Azure project for this site. I think. Do we need to do the dance? I still need to write the application that makes the hard drive icon appear somewhere on the screen. So with that, we now have added the site. What we're going to do, we have the front end side, which drops the orders into the queue. So now we're going to do the back end and say add new worker role project. And the one thing we've done here, kind of to give you a little bit of a start for quick prototyping, is we added a worker role with a queue. So worker role with the Service Bus queue, and that we're going to add this to the project. And really what we need to do in that project, as soon as that shows up, I wish I knew. I will not complain. But I'm fairly sure it was faster when I tried that last time. So here we have the queue. Cutely already, processing queue is the name of the queue that we're using also in the client. Oh, look, we have Scrum. I used to be able to turn this off simply by not having Outlook running. I think that's over. And so I run, and I go and receive here, so I get the messages out, and then I, instead of processing them, it simply writes that to the log. That's enough for now. Once I have that message, I go complete it. Completing means I first peak lock it out. That's the default mode, and I complete it, which means I take it back. So all I need to add here is configuration, so that's also set up. So I go into the worker role with the SB queue. That has some config, and the other side also has some config. So here we go and into the config of this file. Visual Studio really has a bad day. And here is the settings, and in the settings is the magic thing that this depends on. And by default, the name here, or the string, is kind of preset with your namespace. You have to go and replace that value to make that work. So we now have the concept of connection strings in Service Bus. So you don't have to go and have this triad of namespace and account name and account key. So you can go and make a single expression. I'm going to steal this from the config that we just looked at, because that's actually a complete connection string. So I'm going to go and take this from here. I'm going to put that in here. Fine. Good. And then we're going to start the whole thing together. And this time I'm starting this with F5 in the Windows Azure Compute emulator. I think. Ah, yes. I apologize on behalf of Microsoft Corporation. So far, it all worked. It was just slow. Now it didn't work. Now I actually have to go back into, so I got to close this and simply run. I'm still learning the wonderful ways of the new shell. Don't run away because I screw up the demo here. All right. So I think we were here. Yep. It's good. Demo saved. I will not do that tomorrow. This is my dry run. No, it's not. So let's try it again. I said, please, let's try that again. Killing my IE? That's a great idea. You mean with all the serverless stuff? Yes, I will try that. So build started, build succeeded. Would you please? What you doing? Deploying. So now we have, good. So now we have the order site, and we have this the worker role showing up here. So that's starting up, and that's going to start listening. We're going to have the site pretty soon, I hope. This is good garbage. Oh, the suspense, oh, the drama. I don't know what's suddenly so slow. I will blame the pre-release operating system. That seems to be opportune and easy at this point. So the service bus connection string got read, so we're listening. Of course, now the website is also taking its sweet time. And this is an Core i7 processor, not that you think that I'm coming to you with subpar material. Okay, there we go. So we're going to leave that at username. We're simply going to go and have 2 rocks, 2 papers. We're going to submit a message. And what we'll see on the other side, hopefully, is that we'll process that message. There we go. So the message came in on the other side, and this piece of code here corresponds, or this log entry corresponds to us doing that trace in the worker role down here. So that already got the message. So it gives you the start point to do this. Now, you want to go and start with this, and then you want to do some healthy refactoring, because you want to do all those things async. There's a tension between making it simple in the Visual Studio template and doing it super efficient. I can only recommend, and that is true for everything, do everything async. I'll just give you some data. In Service Bus, specifically on the relay call path, as we shipped in January 2010, we were running the relay, or we were running Service Bus on 96 nodes per scale unit. And then we went in one milestone, 3 months, and went and did nothing but just cleaning up the code and getting rid of all the synchronous code paths. We deployed the new version and shrunk the deployment to 32, same capacity. Async is the one thing you can do to drive efficiency into your system. So this is all, as soon as you use our begin and end methods, you effectively run on the I/O thread pool, you run on I/O completion ports. It's the best thing in the world. It's true for HTTP, it's true for us. You always use begin, send, end, send, use begin, receive, end, receive. The downside of that is that with the current tooling that we have, or to make this work with Visual Studio 2010 and to make it work with 2012, to make it work with 4.0 and 4.5, the compromise that we currently need to make is that we can't use async and await, the actual programming model for this in C#, which is going to make that fairly simple to do async. So right now we're giving you a synchronous thing. If you do any serious programming in this, if you have high performance systems, you want to go and switch those things to async. But these are a number of the new additions that we have in Service Bus for brokered messaging, improvements, connection strings, that we have the tooling inside of Visual Studio, that we have the templates in here that will give you an easier time to go and integrate all those things into your application to work with them in Visual Studio. So much as an insight into that space. And now it would be nice if Visual Studio would actually let me just simply stop the debugging. Thank you. All right. So what do queues give you? So this was just a simple example of sending into a queue and getting data out of a queue. What do queues give you? They give you load leveling, load balancing, offline and batching in the simplest case. So first of all, load leveling. If you have data that goes into a queue in bursts, and you have a receiver, and that receiver is simply doing what this code just did. Get a message, process the message, get a message, process the message, get a message, process the message. That worker can never be overstressed. That's opposite to HTTP, where lots of requests can come in, as many connections as you can make, and work is being scheduled immediately based on the incoming requests. Right? There's a little bit of a backlog of accepting those connections, but basically you're tuning towards connections, you're not tuning towards work. Here, because you're pulling, you're tuning towards the work. If you can do more work, you simply have more loops that go and get messages out of the queue, and you can have concurrent receivers. That's what load balancing does. So you can load balance work onto the same machine, onto multiple threads, or onto multiple cores, or you can actually go and take the same queue and balance it over multiple machines, multiple nodes as we call that. And the load leveling makes sure that nobody gets overstressed. Offline and batch means you can use a queue as a mailbox for a device or something that's not online all the time, like a mobile phone, or an application on a mobile phone. And you can also use batching. So if you are collecting data during the day for 6 hours, and only then want to spin up a role, and the role goes and processes all that data in batch, but in order, you use the queue as temporary storage for that data. Topics are a infrastructure that is similar to queues in the way that it's completely compatible with queues from the end queue perspective, but you can have multiple outs. The simplest out, and that behaves exactly like a queue, is where the rule on the queue, on the subscription, that's how that's called, is true. Every message that's coming into the topic will be selected for that particular subscription, which means that a subscriber, whoever pulls on a subscription, can get that message. So that gives you effectively a queue. What you get in addition to this is, well, as many subscriptions as you like, and all of them can have the true clause, which means you can now use this for message distribution. You can have N subscriptions, up to 2,000 subscriptions per topic. So you can have 2,000 destinations where those messages can go, and we're going to make a copy for each single one of them. You can go and use partitioning. So you can create rules on those subscriptions which have, let's say, cover a certain number range. So you have 10,000 logical subscriptions in the system. You have one subscription that covers the first 1,000, then the next one covers the next 1,000. So if you have partitioning in your system, you create rules for those partitions, and so each partition gets their messages based on that subscription. And you can go and reshuffle them. You can actually go and change those rules in the running system. Or you can go and do things like evaluation of particular rules out of particular properties and particular values. So that gives you distribution or partitioning. The messages that flow in the system are brokered messages. They're separate and distinct from the messages we have in WCF. In WCF, we have SOAP messages, and they're a full envelope that's expressed in XML info set, and there's headers, and there's a body. That whole SOAP message is a thing that you would stick into the body here. So this is a frame as much as HTTP has a frame. So think of this brokered message more like an HTTP frame than anything else. They're properties. Some of them are system properties, and some of them have predefined headers in HTTP, and the rest of them are custom properties that you can use. The difference between these properties, these keys, and the SOAP headers is that they're completely external, and they're externally parsable by the system, and the system knows about them. And so the rules that you define for your subscriptions are running on those properties. So what we typically find people do or more often find people do, is to ditch the notion of a body altogether and simply express all their values in those bodies. This goes very nicely with a very simplified profile of HTTP that I wrote that on my blog as a super short post, which I called NHTTP, for non-hypertext transfer protocol. And it's a super simple constraint. Don't send entity bodies. That's it. So take all your data and just put it onto HTTP headers. Key, value, key, value, key, value. And so in order for you not to have any collisions and to be able to make them enumerable, just prefix them with P- for property. The nice thing is, because of the HTTP extensibility characteristics, this works, because HTTP, all the intermediaries must forward those headers. And it turns out that even the simplest HTTP stack has the ability to parse headers. There's no external JSON parser needed. There's no XML parser needed. All you need is your HTTP stack. And so you get key-value pairs very easily. You can set them back and forth. You can use posts. You can use gets. It all just works. And turns out our HTTP API that we have for Service Bus is actually working in that way. Because for us, these properties map straight onto HTTP headers back and forth. So HTTP headers become message properties become HTTP headers. So we're using that for our HTTP protocol. So you actually don't have to send message bodies. And the message body in the way how we use HTTP in Service Bus is mapped straight onto the entity body in HTTP, and that's why we also have the reserved content type property, which we actually use for that mapping as we go from brokered message to HTTP and back. So you can literally think of that as an HTTP frame, even though we're transcoding that also into our next protocol, our next strategic protocol that we're driving with a number of industry partners called AMQP. And AMQP, the Advanced Message Queuing Protocol, I don't think I have a, well, I have a slide for that kind of on the side there, is a protocol that we've been co-developing with a number of industry partners. We've joined the effort a little late. About 2 years ago, my peer, David Ingham, is on the AMQP standardization committee. He's the co-editor of the spec. And we're going to have AMQP support in Service Bus in fully interoperable fashion. We're testing against Apache Cupid. We're testing against RabbitMQ. So we're testing against all those brokers, and we're going to have that in a released version, we hope, also towards the end of the year. We currently are running already with a number of customers a preview program, a closed preview program also where we're doing interoperability. We have a number of commercial clients where we're already starting to do planning for AMQP, large-scale AMQP deployments with them. So AMQP is going to be our strategic protocol for the future, and that's also our interoperability bet for the future. And the relay will, so I often get the question, what is with the relay and why is it in WCF and why can't I do anything else with it? The relay is likely also going to adopt AMQP as the foundational protocol, and once we have that, then it really is just a matter of whether you have brokered asynchronous messaging, right? Send a message into a queue, get the message out of a queue, or whether you have straight through, direct messaging, but both using the same kind of framing protocol, which we can then also support with all these different libraries and can also very easily map to WCF. So AMQP, that standardized protocol is the big bet that we make on the messaging side from the Service Bus team, and it's an open protocol that we define with the industry, and it's binary. It's not JSON, it's not XML. It's super compact, and it's built for high performance for anything from financial transactions to device telemetry. The rest of the programming model is effectively you're getting abstracted from the fact whether you're using SBMP, which is our current protocol, which is based on WCF's net TCP stack, or whether you're eventually going to use AMQP. We're extracted by this by the APIs that we have. We have the messaging API under the covers, and then we have the WCF service model on top if you're using the messaging binding. So you can either use WCF if you're using WCF, and use the net messaging binding in exactly the same way as you would be using the MSNQ binding, or use the messaging API directly, or you can use our REST and HTTP API, and the REST and HTTP API is used in all of our other SDKs. There's a Node SDK, there's a Python SDK, there's a PHP SDK, and there's a new Windows 8 SDK that's out. And the Windows 8 SDK is, I think, on the next slide, where I'm already running over. So I'm going to skip the access control piece, because I just want to get to the, you can watch, the nice thing about TechEd is you can actually watch the presentation. So you can get that part out of the other presentation. So I'll just show you what we have in the Windows 8 SDK. I'm not going to show you the SDK. I'm going to show you the sample that Will Perry built, who's one of our great rockstar testers. Will is working in our test organization, and it's kind of the best example of why working in a test organization is not a boring job at Microsoft. Because he's building a lot of those integration pieces. He's our king of the open source of our GitHub, and is building all these demos and all the stuff that he gets to build to torture the product is also very cool. So he built this. So this is a Windows 8 app. It's using the Windows 8 SDK, and it's effectively doing the things that I've been doing in code. So it's creating a queue. So here's actually the code that goes with it. So you can go and create the queue. And there we have the async method. So we're using async await here in Windows 8. And this is a managed library for Windows 8. So I can go and create a queue. And I can go and send a message that's sitting here. And then I hook up the receiver, so I have the receive and delete. And then I'm going to show a toast. And then I'm going to delete the queue. So that's an integration for Metro-style apps, where Metro-style apps can go and communicate using Service Bus very easily using this SDK. And of course, the normal SDK, the full SDK, will work in desktop mode. So in the constrained environment that is Metro-style apps, for that we're going to have the integration for for messaging. We're not going to have the relay capabilities yet, because in the Metro-style environment, applications get tombstoned as they get tombstoned on the phone to preserve energy. Which means at that point, if you have an active listener, that active listener would get suspended. So it would no longer listen. That kind of defeats the purpose. So using messaging is actually the right thing here. And the complementary thing we're adding, as I said earlier, is WAZUG is our infrastructure for push notifications. And that comes here. So I'm going to talk about that in a moment. Let me talk about pricing before we get there. And I will promise that I'm going to be done in 5 minutes. Pricing, $1 for a million messages. A message is an operation, is a 64K block or smaller. Right? So if you send me a message and it's 128K, it's 2 messages in terms of charging. We're charging you when you send that message into the queue, but we also charge you when you get that message out of the queue. That seems unfair, but think about the case where you send a message into a topic and let that sit there. Well, we'll have to go and do something about that. Or you send the message into a topic and you have 2,000 subscriptions. Well, then one message becomes 2,000 subscriptions, so we have to do something about that as well. So so the pricing model is effectively what you use in terms of resources on the system. So it's 1 million messages, costs you $1, or 1 cent for each 10,000 messages. And 10 cents for each 100 relay hours. So the relay hours are, that sounds complicated, it's very easy. Every time you create an endpoint with the relay, and I've done that twice. So I created this relay endpoint for HTTP. There was a single listener on it. So for that single listener, for that single endpoint, it is 10 cents per 100 hours that thing is online. If I have these multiple listeners, I have 3 listeners parallel, up to 25, that is also just 1 endpoint as per that definition. So it's not per listener, but it's per that name that we maintain in the system. And that is 10 cents per 100 relay hours, and it's also just based on us holding capacity for you to go and create that kind of connectivity. So that's what the pricing is. In addition to that pricing comes standard Windows Azure data center egress traffic charges. So you can also look at this as us having a surcharge on your messages as they go in and out of our system. But that's it, right? This is all you have to go and pay for the system, and for that we're managing this for you. You get support. We're not losing your messages. We're replicating that data on the back, et cetera, et cetera. So that's the only. These are the only. Everything that's on this list here. That's what you have in terms of cost. So some features. WAZUG cross-platform push notification integration for Service Bus. Will be new entities, same message format, so you send the same kind of messages. We'll have a feature that we call forward to, which allows composition. So you can create a topic, and you have a subscription, and the subscription goes into an application proper, into that application. And you can have another subscription that's for notifications. And you can hook up that notification with forward to into a notification topic, which then pushes out. So you can go and create these routes where you can combine both in-app messaging and out-of-app messaging using these compositions. And the delivery model here is that you send regular Service Bus messages with properties, and we're mapping them so the device comes and registers with us a target. We manage all the targets. Targets means a target is a pair of a registration with us and a push notification URI or device ID. So we manage the device IDs for you, and you can have on a single notification topic 5, 10, 15 million targets. And we'll also have tags that allow you to do filtering. So you can send a message, one message, like a weather alert or a news alert, and we're dealing with sending it to 5 million or to 10 million within super short period of time, seconds. So we're building out a super large infrastructure that creates massive parallelism and that allows us to push as hard as the target infrastructure allows us to do that. So we're actually, the biggest thing we're concerned about right now is not our scalability, but the scalability of the other side, so that we don't show up and take out the Windows notification system. And so to that effect, we're actually we're working with the Windows notification system test team and their operational team so that we can go and push as hard as we can without putting their infrastructure at risk, because we can push pretty hard. The general model for how those notifications are mapped is something that's unique to this service that nobody else who has the notification services actually has. Because we don't let you send the payload. We just let you as you register, as the device registers, it gives us a template. So the design of how that payload looks is with the app. It's not with the server, because today, if you look at other notification systems, other abstractions or push notification systems, all they do is effectively they deliver the message for you. So you can give them a payload for Apple, and they'll deliver that payload. But that means that the payload is actually defined on the server. What we do here is we use the normal API for Windows 8, just to give you that example. And you create a normal toast. And in that toast, you use placeholders instead of normal text. So you just say $ location in Russian and $ condition image and $ temperature in Celsius. So these replacement strings, and then you use one gesture, one extra API that we give you, which takes the target URI, the channel URI, plus that template, which you've defined with a normal Win80 API, and you give that to us. As we get a message, we take the key value pairs that we have, that you give us, and we map them into this template that you gave us on a per device basis, right? 5 million devices, 5 million completely owned, customized things, and we're going to push you that tile, exactly that tile, as mapped based on your input, based on that rule on a per device basis to you. So you can have 5 million devices, and you can have 5 million completely customized notifications, different colors, different schemes, different widths, different compositions, and we're going to do that all for you. And that's something that's fairly unique. So that's something we're going to hope to preview for you, but also already with a license where you can actually go and use this by the end of the year. When I said, December 56th, it's might be what this becomes, but we're currently hoping that we can get this out before Christmas. Service Bus EI and EDI, that's the session. That's actually not right, but they haven't changed my deck. Service Bus EI and EDI is something that the BizTalk teams built. The BizTalk team is hard at work building the next version of BizTalk Server. So BizTalk Server, I always get asked, what's the future of that thing? It has a bright future that we're continuing to invest in it. Service Bus EI, EDI Labs is kind of a preview into the future of BizTalk, brand new things that they have built. And we're not yet clear how we're going to deliver it. That's why it's called Labs. But that's something that's a future investment for doing integration, EI, EDI. Likely similar to the dedicated cache that you've seen Scott demo, where you will be getting some packages that you can go and install in roles that you run yourself rather than something that's rolled into multi-tenant service bus. And then finally, as I said, we're not in the portal. Well, there's a plan. So you'll be able to create new namespaces in the portal, and you'll be able to go and see statistics, how many queues you have, and how many messaging operations and relay hours you have. Look, I have another meeting. So you're going to have statistics on a per entity basis. You're going to have statistics on a per namespace basis. You'll be able to create queues, delete queues, manage descriptions, do all those things in the portal. So we have the wireframes there, which means there's work in progress. We're hoping to get this out in fall, when in the fall time frame when all the other services release. The new portal is then going to come out of preview, which means we're going to get rid of the Silverlight portal. And at that point, we're also going to be in that new portal as well. So with well, I did a 75-minute talk. It is a 75-minute talk, apparently. So, again, I apologize on behalf of Microsoft Corporation for the late arrival of this session. It's easy to blame that on my boss, for real. So this is what we have. This is what it's for. It's an overview, obviously. I encourage you to go on channel, if you're not a tech ed, go on channel 9. Watch the session from, you can do that tomorrow. There's a session from Tech Ed North America. That's kind of the deep dive to this session. So I'm going to do that on Friday. You can see it already tomorrow or tonight even if you can't wait. That's on the site, and also on Channel 9 you'll also find some deep dive on Service Bus and ACS. Now we integrate with all those things. But Service Bus, if you look across cloud environments, across the PaaS offerings, is a fairly unique offering because we're uniquely there to go and bridge the gap between on-premises, off-premises things, between points of sale, clients. So we're there as the bridge between all those things. And it's not a VPN technology where you basically just go and take a network and integrate it with another network. But we're really in a technology to go and bridge between, kind of do surgical cuts through network infrastructure and do that either in a asynchronous or in synchronous fashion. So with that, I hope that was somewhat interesting, entertaining. Thank you all for coming. Also on behalf of Scott, and have a good night.